Hey everyone, welcome back to Bazai. Today we're demystifying one of the most fundamental concepts in modern computing, virtualization. Whether you're building servers, running containers, or deploying apps in the cloud, virtualization determines your system's efficiency, scalability, and security. Let's walk through the 4 types you'll encounter in the wild. Let's start with the original style, traditional, bare metal. Here, multiple apps run directly on the same operating system, installed on the physical server. They all share the same kernel, and there's no process isolation. If one misbehaves, it can crash or affect the others. Networking and hardware resources are tightly coupled with the OS. This method is simple, low overhead, and fast, but not ideal for security or large-scale multi-app scenarios. Next up, virtualized servers, the classic VM-based approach. Here, a hypervisor sits on your physical machine, emulating hardware for each guest OS. Each VM can run entirely different operating systems, like Windows or Fedora, isolated from each other, even if they're on the same host. You can run multiple apps on separate VMs, keeping security tight and dependencies separate. This method revolutionized data centers and laid the groundwork for scalable, multi-tenant cloud hosting. Now let's look at containers, the star of today's cloud-native world. Containerization uses the host OS kernel to run mini-environments called containers. Each container isolates its process, libraries, and configuration, but shares the underlying kernel. A container engine, like Docker or Containered, manages networking, resource allocation, and lifecycle. Containers launch in seconds, use little overhead, and are perfect for microservices, CI/CD, and portable deployments. Still, they're less isolated than VMs since they share the host OS, but they're fantastic for speed, density, and developer workflows. Finally, a blend used everywhere in the cloud, containers on VMs. Cloud platforms like AWS, Azure, and GCP commonly run containers inside dedicated VMs. Here's how it works. The physical server runs a hypervisor, spinning up VMs with guest operating systems. Inside each VM, a container engine launches and orchestrates containers. You get the best of both worlds, deep isolation and security from VMs, agile deployment, and density from containers. This hybrid model handles multi-tenant workloads, compliance, rolling updates, and disaster recovery. Drop your questions in the comments, and don't forget to subscribe to Bazai for clear, practical engineering explainers every week. See you next time.